All right, guys, we're going to talk about our notes from lesson 1.8 today. These notes talk about square roots, and also we're going to talk about cube roots, okay? We've talked about square roots and cube roots previously in this chapter, so a lot of this should be review. Plus, you've also seen square roots and cube roots used over the last few years as well, okay? So what is the value of 2 squared? Well, you can think of that as a couple different ways. You can think of that as 2 times 2. But what we really want in the end is the entire value, which is 4. 5 squared would be 5 times 5, and that value is 25. And 7 squared would be 7 times 7, which is also 49. Okay? So now it says, what number can you square to equal 81? So you're thinking, what number times itself would give you a total of 81? So that number is 9. So 9 squared, or 9 times 9, is equal to 81. Okay? And then same thing for the next one. What number can you square to equal 100? So again, what number times itself would give you 100? And that number is 10. Okay, so 10 squared, or you can think of it as 10 times 10. All right, so when 9 is squared, it equals 81. So we can say that 9 is called the square root of 81. This little part right here is called a radical symbol. All right, and this particular one is called a square root. Technically, the root is hidden in a square root, but technically there's a little 2 that's hidden. And we talk about hidden numbers a lot in math, and that's just another one that we have here, okay? So this is a radical symbol, and it has a root of 2, okay? So the square root of 81 is 9. So our practice problems are going to be very similar, okay? So you can either just think of this on your own, okay, or you could use a calculator. If you're using a calculator to do these, you would hit the second key, and then you would hit the x squared key, and then, for example, if you're doing the square root of 16, you would type in the 1 and the 6, and then you would hit equals, okay? Or you could just ask yourself, what number times itself gives us 16? And the answer would be 4. For number 2, the square root of 9, again, you can type it into your calculator or ask yourself, what number times itself gives us 9? And that answer would be 3. And then again, same thing for number 3, what number times itself would give us 100? That would be 10. Okay? So, it says, write in your own words, write in your own words how to find the square root of 25. That was the same question that I just asked you 3 different times. The question you ask yourself is, what number times itself is, in this case, 25. So what number times itself is 25? That number would be 5. So we would say the square root of 25 is 5. Okay? Now, our book does this a little bit differently than when I learned talking about square roots. And so this is how we teach it now. Positive square roots, negative square roots, and then sometimes we have positive or negative square roots. Okay? So in our book, typically, if they ask you for a square root of a number and it does not have any sort of a sign in front of it, we're going to be talking about only the positive square root. Okay? The negative square root is if we have this negative sign out in front. It is not underneath. Okay? So if it's out in front, we move that over to the answer. And we're going to be talking about the negative square root. Or sometimes it has this sign out in front, which again, we would move it over to our answer, and that stands for the positive or the negative answer. And so that would either be positive 10 or negative negative 10. But most people just go ahead and write that as it's written right there. Okay? So the reason for that is, you know, a lot of times, if we think about it, what number times itself is 25, like the question asked there at the top of the page, it isn't true. It's not just 5. 5 times 5 equals 25. But if you really think about it, if you take negative 5 times negative 5, those two negatives cancel each other out, and that also gives you the answer of 25. Okay? So technically, there's a positive and negative answer to all of these square roots. But our book specifically tries to make it a little bit easier for you guys and only worry about positive answers most of the time. Okay? That is going to change though when we go to the next page here. Alright? So, let's do these practice problems. Again, this is pretty simple stuff. I don't expect you to have the square root of 1.21 memorized, so you can use that calculator again. You're looking for the second key, and then the x squared button, okay, to type in a square root. And for right now, we just bring this positive and negative down, and then again, we use that calculator to answer the square root of 1.21. And that would give us positive and negative 1.1. All right, number 2 looks more complicated because it has a fraction. And if you're good with your calculator, you can type that in just as it appears, no big deal. But some of you aren't that great with putting in fractions into your calculator. So what you might think of is anytime we have a square root or a cube root, we're going to find out, it actually gets applied to everything on the top and also everything on the bottom, okay? And then don't forget about that negative sign that we have out in front as well. So now, using your calculator, you can answer the top, and that would give you 5. You would answer the bottom, which would give you 6. And notice that I also have already brought over our negative sign that just stays out in front. So we've got negative 5/6, okay? Now, number 3, when you try to type that into your calculator, okay, you have quite a bit of an issue here. Most of you are going to get an error if you type it into your calculator correctly, okay? So remember, we're asking ourselves what number times itself, okay? So the same number times itself gives us negative 16. So most of you are going to say either 4 or negative 4. So let's think about that for a second. If I take 4 times 4, we get positive 16. And if I take negative 4 times negative 4, those two negatives cancel out and still give us positive 16. So there is no way that I can get a negative answer if I'm multiplying the same number times itself. This cannot happen. So it is no solution. Okay? This cannot happen. All right? All right. Now, the next part is talking about solving equations. Last year, you guys should have done a lot of solving equation stuff. Solving equations with one single step, okay? So last year, you guys would have worked on addition, subtraction, multiplication, and division. So right now, we're going to take it a little bit further, and we're going to find the opposite of squaring something. So here in number 1, it says solve equations using our square roots. We need to get the a value by itself. And as you guys hopefully remember from last year, anything that I do to one side, I have to do to the other. So I drew a line here to split it into a left side and a right side. And now I want to get the a value by itself. So right now it's a squared. So I need to do the opposite of that, which is the square root. And again, like I said, last year you guys would have done a lot of this. And you should remember that if you do something to one side of the equation, you have to do the exact same thing to the other side of the equation. Okay? So, what happens is this square root and the square, they cancel each other off, and that a value drops down. Over here, again, we use that calculator. Square root of 289 would give us 17. Now, the only difference is in our book, okay, when we're talking about solving equations, we're going to have 2 answers here, okay? So I briefly talked about it on the page before this. So 17 times 17 is 289, but so is negative 17 times negative 17. So we're going to add the positive and the negative sign in front of that. So I want both answers. Okay? Same way with number 2. I go ahead and I draw my line. The opposite of squaring something is the square root. So I square root each side. That cancels each other out on the left. T drops down. And I use my calculator to get 13. And then again, I think about it could be 13 times 13, and it could also be negative 13 times 13 to give me that answer. So I'm going to keep both of those possibilities. Okay, number 3, same thing. We're going to square root each side. That cancels out on the left. The m value drops down. I'm going to have a positive and a negative answer here. And it's 0.3 or 3/10. Okay? And number 4, same thing. Even though it's got a fraction, we put it over the entire thing. Again, if you're good with your calculator, you can type that in, no problem. If you're not so great with your calculator, remember that what happens is the square root gets applied to the top and to everything on the bottom. And so we would have the square root of 4 is 2, the square root of 25 is 5. And then again, because this is solving an equation and I don't know if they're looking for the positive or the negative, I'm going to use the positive and negative sign out in front. Okay? All right, so the next thing, we're going to be talking about a perfect square. Okay? So a perfect square, if you remember the demonstration that I did in class, I put out a whole lot of cards and I said, okay, what's the smallest square that you could make with these? Okay? And we noticed that it was 4 cards. And I said, okay, what's the next largest square that you could make? And it was 9 cards. Okay? But the best way to talk about this is a perfect square is called the product of 2 equal integers. And this whole chart down here are examples. Okay? So, these are all examples of perfect squares. Okay? So, over here on the right side, okay, if I think about this and I take 2 to the power of 2, or 2 squared, or 2 times 2, I would get the answer of 4. Okay? If I took 3 times 3, I'd get 9. If I took 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. All the way through. So each time that you go up by 1, okay, and then you multiply that together with itself, or you square it, it will give you the perfect square on the other side. So we're up here at number 6. So 6 times 6, or 6 squared, is 36. 7 squared would be 49. 8 squared is 64. 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. Okay? All right, down at the bottom, we'll briefly talk about a couple patterns, but we won't spend a whole lot of time on this as of right now. But there are some very interesting and strange patterns that happen with square numbers. Okay, most of you can see over here on the right side the square roots. We can just add 1 every time. Okay, that's no big deal. But when we're talking about over here on the left side, something weird's going on. So 4 and 9, that has add 5 to it. Okay, and then we add 7, and then 9, and then 11. And 13. Okay, and so every time there is an odd number between from one square to the next perfect square to the next perfect square, and so on. And what gets even a little bit more weird is if you take the 2 and the 3 from over here, that gives you the plus 5. If you take the 3 and the 4 over here, that gives you the plus 7. And the 4 and the 5 gives you the 9. Okay, so there's quite a few different patterns going on that we'll talk about more eventually. Okay. So let's flip on over to our cube roots. All right, our cube roots. So again, we've talked about cube roots before. 2 to the power of 3 is the same thing as 2 times 2 times 2, which gives us a total of 8. 5 times 5 times 5, which gives us a total of 125. 7 to the third power is 7 times 7 times 7, which is 343. All right, and then this is where we start to think about these cube roots. So what number can you cube to get equal to 27? So again, that's really kind of like the number times itself and then times itself again. It has to give me 27. And that would be 3 times 3 times 3, or 3 to the third power would give us 27. All right, same thing here with number 64. What number can you cube to get 64? That would be 4 times 4 times 4, or 4 to the power of 3. Okay. All right, so when 5 is cubed, it says it equals 125. So we can now say that 5 is known as the cube root of 125. All right, so on the front page, we talked about a hidden number. Notice that here, this root is not hidden when it's a cube root, okay? So this is, again, still, it's called a radical sign or a radical symbol. And then out front is that little 3, which stands for the root. Okay, basically what that 3 stands for is the number of factors, okay? So the number of things that multiply together to give you the number underneath, okay? So that 3 is a helpful little reminder, okay? So you're saying what number times itself 3 different times would give you the answer of 125. And that number is 5. Okay? All right, so we're doing the same thing here for the practice problems, okay? So again, I don't expect you to have these memorized, so you'll need to know how to type this into your calculator. It's a little bit different than the square root. On most of your calculators, you're going to type in a 3 first, then you're going to go up and you're going to find that second key, and then you're going to find what we refer to as the caret key a lot. And then if you're doing this first example, you would put in the number 216, and then you would end up hitting the equal symbol, okay? So, in our case, that would give us 6. In number 2, what number times itself and then times itself again gives us 729? That would be 9. And what number times itself and then times itself again would give us 1,000? That would be 10. Okay? All right, now we have something interesting that happens with square roots and cube roots, okay? And so, it says explain why the square root of -4 is not a real number, but the cube root of -8 is, okay? So remember we talked about this on the first page, that this is no solution. It cannot happen. And the reason for that is, again, I cannot take a positive number times a positive number and get a negative answer. Okay? And same thing again here for the square root of -4. I can't take a negative number times a negative number and get a negative answer. Both of those end up becoming positive. And so that's why we can't have the square root of -4. There's no way that I can take the same answer and multiply itself to get a negative number. However, when I'm talking about a cube root of a -8, this time I can take -2 times -2 times -2, and my answer really is negative 8. So when you add that third number in there, that third option, it can work now. So a negative can work with a cube root, okay? All right, and we'll talk about that a lot throughout this lesson, okay? What is a perfect root? Cube, okay? So a perfect cube is the product of 3 equal integers. Okay? So, for example, like 2 times 2 times 2. Okay, so the perfect cube would be 8. 3 times 3 times 3. Perfect cube would be 27. So on and so forth. Okay? So, a little word problem here on the back side. Okay, it says Dylan has a planter in the shape of a cube that holds 8 cubic feet of potting soil. It says solve the equation 8 equals s to the third power to find the side lengths s of the container. So just like what we did with the square root, to get rid of a square root, we want to now get rid of a cube root. Okay, so to get rid of a square root, to get rid of a square, we took a square root. Now we want to get rid of a cube, or a power of 3. So to get rid of that power, again, we use the radical symbol, but this time we have to use the little 3 in front of it so that it cancels out the cube. Okay, so over here on the right side of our equation, those two cancel each other out. And what number times itself, and then times itself again, would give us 8, would be 2. And because this is a real world problem, we have a label that goes with it. So each side would be 2 feet in length. Okay? And our last one says an aquarium in the shape of a cube that will hold 25 gallons of water has a volume of 3.375 cubic feet. We're going to solve s to the third power is equal to 3 and 375 hundredths. Oh, sorry, thousandths, okay? And we're going to take that to the cube root on each side. So again, on the left, it cancels out. And on the right side, we get 1.5. And again, because it's a real world problem, stands for feet. All right, so we have a side length of 1.5 feet. All right, so that finishes up our notes on square roots and cube roots for lesson 1.8.